start our next section of this. Shh. Quiet, please. So we're still looking at equations of parabolas. Okay? So still looking at equations of parabolas. So I included, nice. I included that table again. Thank you. Hey. Hey. If you were confused about what we did yesterday, you're going to get more confused if you don't pay attention. So I included this table again. Okay, so we can refer back to that as we go through all of these. So the ones that we're going to use to get today is, again, those top equations. I don't need the comments. Okay, so we need to figure out which equation we're using.
Look at these two strangers I found. They were lost, locked outside.
I started, and you're late, so can you just sit down and get started with us, please? We're also going to use the vertex.
I gotta pass.
Okay. We will use the focus. Okay, and then the last one we'll use is the directrix. Okay, so those are the pieces that we're going to use today as we go through our notes. So again, we're writing out the equations of parabolas. So if I look at the examples below, okay, that first one, we're going to be given two pieces of information, and we're going to need to form the equation of a parabola in standard form. Okay, so standard form is what we did yesterday with the parentheses and the square and then a number outside. Okay, so with this first one, I'm given a vertex and the directrix. Okay, vertex is always in the form h comma k. Okay, it doesn't matter which form of the equation it is, your vertex is h comma k. Now if I look at the directrix, that is y equals -6. I'm going to look at my table above where it says directrix. Okay, so that would be here and here. Well, the one I have is in the form y equals. So I'm going to use this one, meaning I'm using this form of my equation. Okay, so your first step with these is to pick out which of these forms you have to write it in. In this case, since I was given this directrix is in y equals, I'm going to use this form here. Make sense? Mm-hmm. All right, so that means I'm using y is equal to a times the quantity x minus h squared plus k. So at the moment, I already have h and k. The only piece I'm missing from this formula is a. Well, if I look at my directrix, I can use this formula. Okay, so my formula for directrix is y equals k minus 1 over 4a. So I can get a from this. I know k, right? That's negative 5. Now this y here, it already gave us what that equals. It equals negative 6. So I can plug in negative 6 for y. Okay, because that's what your directrix equals. K should be negative 5 minus 1 over 4a. Okay, so from here we want to solve for a. So we're going to add 5 to both sides. So we have negative 1 is equal to negative 1 over 4a. Okay, I need that out of the denominator. So I'm going to multiply both sides by 4a. You can by negative if you want, yeah. Okay, so when I do that, I get negative 4a is equal to, these ones will cancel out, negative 1. Okay, and then to get a by itself, divide both sides by negative 4. So you'll get a is equal to 1/4. Okay, so from there, I just need to plug all of those values into my equation. So I still have y equals, I found a is 1/4 times x. My h value is 4, so I'll have minus 4 squared. And then plus my k value is negative 5. So I can say minus 5 or I can say plus negative 5. And that would be your answer.
Seriously?
Yep.
I'm
Okay, so this one I had vertex and directrix. Okay, so for all of these, you're going to be given two different things. So you're still going to have to figure out which form of the equation you're using. Any questions on one before I go to number 2? All right, so if you look at number 2, again, we're given the vertex, but this time we're also given the focus. Okay, so vertex, if you look above, it doesn't matter which equation, it's always h comma k. Okay, so whenever you're given a vertex, is always h comma k. So h is 1, k is 3. Now your focus, I have two different forms up here. Okay? Now, if I look from my vertex to my focus, in this form, my h stays the same. In that second form, my k stays the same. So what I want to do, I want to see if my h is the same in both of those points I'm given, or if my k is the same in both of those points I'm given. Okay, so if I look at my 2 points here, both of these values in front are the same. Okay? If I look at this one, those stay the same. Okay, so it's going to be in this form.
What if it's not?
Then your second number will be the same. So my focus here is h comma k plus 1 over 4a. Okay, so now since my h's were the same, I can say I'm using that same equation, y equals a times x minus h squared plus k. Now again, I need to solve for A. Okay, because I already have H and K, but I still need to find A. Well, I can use this 5 and that formula to find that 5 to get A. So that second coordinate there in my focus, 5, you have to get there by taking your K value, which is 3, adding 1 over 4 times A. And we want to solve for that A. So I'm going to subtract 3. So I have 2 equals 1 over 4A. Multiply both sides by 4A. Okay, they cancel here. So I have 8A equals 1. Divide both sides by 8. A will equal 1/8. Okay, so now that I have A, H, and K, I can plug all of those into my formula here. So I have Y equals 1/8 times X minus H, H is 1, that's squared, and then plus K, K is 3. Okay, questions on number 2? All right, so looking at the back, now, again, you're given 2 different things here. This time you're given the focus and the directrix. Okay, so since I'm given that directrix again, okay, my directrix is x equals -2. So if I look back at the front on my table here, which directrix says x equals? That second one. Okay? So since this directrix says x equals, I'm going to use this form for my equation. Okay, so my form here will be x equals a times y minus k squared plus h. Okay, so that's the form I'm going to use this time. So since I'm using this form, I want to look back at my focus in that form. Okay, so if I look back here, my focus is this right here, and I'm going to label that underneath that coordinate. So we have h plus 1 over 4a, comma k. So here would be h plus 1 over 4a, comma k. Okay, so that's what this point is right here. So right now I have k. So k is 6, but I don't know what h is. Now if you're given the focus and the directrix, your vertex is halfway between those two. So it's a midpoint of those 2 points. Okay, so I can find the midpoint between my x values. Okay, so your vertex is the midpoint from focus to directrix. Okay, so I can use that information to find h. So to find h, we're going to take our x value in our focus, which is 5, and add my x value for my directrix, which is -2, and divide it by 2, because I want to find the midpoint of those two. Okay, so when I do that, I get 3/2, okay, which is 1.5. Okay, so that's h. So now I know what my vertex is. It is 1.5, comma, my k value I was already given is 6. Okay, so now I have my vertex. Now I still need to find a, right? Well, just like we did on the front, we had our directrix. Okay, so I can use that formula for my directrix, which is x equals h minus 1 over 4a, to find a. Because now I have x is -2. And I found h, that's 1.5. Okay, now we want to solve for a. So subtract 1.5. So we have -3.5 equals -1 over 4a. Then multiply both sides by 4a so that we can cancel them right here. Okay, that's -14a is equal to -1. Divide by -14, so a would be equal to 1 over 14. Okay, so now I have all of my pieces. So I have a, I have h, and I have k. And I can plug them into this form right here. So we have x is equal to 1 over 14 times y minus k. Your k value is that 6 squared. And then plus h is 1.5. Okay, questions on that one? All right, so if I look at the next one then, our last one, and then I'll let you work on the assignment. So we want to write an equation for a parabolic mirror that has a focus. Okay, your focus is 4.5 feet above the vertex. And the lattice rectum is 18 feet long. Okay? Now it's also telling us this focus is the origin. Okay, since the focus is the origin, that means it would be 0, 0. Okay, so now if I think about this on a graph, okay, my x and y coordinate, or axes, my focus point is right here. Now, above, it said the focus is 4.5 feet above the vertex. Okay, since it has to be above the vertex, that means your vertex is below it by 4.5. So the coordinate for that would be 0, negative 4.5. Okay, so it's making this parabola shape here. So it is opening up. Your focus has to be on the inside part of that parabola. Okay, so now I also have the vertex. Okay, that is 0, negative 4.5. Okay, now I have to find A. Well, it gave me that this lattice rectum here is 18 feet long. So I'm going to go to the front. That's right here. To find that, it's the absolute value of 1 over A. Okay? So, we'll use that 18. That length has to be equal to that formula, absolute value 1 over A. Shh. Stop talking. Now we already know this opens up. Okay, we already know this opens up. So this has to be positive. So that means our A value has to be positive, okay, since it's opening up and not down. So instead of having these absolute value, I can just say 18 is equal to 1 over A. Now to get A out of the denominator, we'll multiply both sides by A. So we have 18A equals 1. So A should be 1 over 18. Okay, so here we have H, K, and A. So I can write out my equation. So we have Y equals, our A value is 1 over 18, times X minus H is 0, squared, and then plus K, so that'll be minus 4.5. Okay, so you can write it like this, or since it has 0 here for H, you could write it as Y equals 1 over 18, X squared minus 4.5. Okay, either way, it's the same thing, just because that H value is 0. Any questions on this one? So you're just using your given information to figure out which equation. Okay, that's your first step. Your first step is to figure out which form you need to use. Then your second step, label all your points, okay, with that table on the front, and then solve to find your missing values to plug into that equation.